In this video, we're going to practice using exponent properties to simplify expressions. We're going to do mostly the power rule and the product rule. So I've got 4 example problems on this slide. And so what we've got here is this is called the power rule. I'm not as concerned that you know that name, but I want you to know how to use it. And so let's look at what happened. If I have a power that's raised to a power, how does that play itself out? And so I know that anything squared is that value times itself. So 4 to the third squared is 4 to the third times 4 to the third. Well, this first 4 to the third could be expanded as 4 times 4 times 4. And the second 4 to the third could be expanded as 4 times 4 times 4. And so once we do that, we can see that, oh, I'm really multiplying 4 by itself 6 times. And so what your shortcut is you can, if you're raising a power to a power, you can just multiply the exponents. 3 times 2 is 6. I'm going to write a lot of these examples using this expanded notation, but that's really just to kind of help you see how to get from here to the shortcut. I would never count off if you expanded it out like this. In fact, I'd almost prefer it because it shows you know what you're doing. But the shortcut is when you raise a power to a power, we're going to multiply those exponents. So now I'm looking at our next example, and what we have is we have 2 to the 5th c cubed, but we have that times itself 3 times. 2 to the 5th c cubed. Okay? So 2 to the 5th c cubed times 2 to the 5th c cubed times 2 to the 5th c cubed. So these 3 values that are being multiplied represent this cubed. Okay? And now instead of writing this out, what I could do is I could expand this out and write 2 times 2, multiplying 2 out 5 times and doing it again here and doing it again here. But hopefully you kind of see where it's going. You're saying, okay, well, if I have 5 2's that are being multiplied there, 5 2's that are being multiplied there, and 5 2's being multiplied by there, we really have 2 to the 15th power. And then hopefully you can extend that logic to the c values. If I have c times c times c, c times c times c, and c times c times c, that's really c to the 9th. And keep in mind, the reason we can do that is because all these values, if it's 2 to the 5th c cubed, that's really 2 to the 5th times c cubed. And if I'm multiplying these values, I can multiply them in any order I want. I can rearrange them with the associative and commutative properties. But once again, your shortcut is that when you have some powers that are being raised to power, you can multiply the exponents. 5 times 3 is 15. 3 times 3 is 9. Let's look at another example. I'm going to take this fraction and I'm going to write out 2 to the 5th over b to the 4th times 2 to the 5th over b to the 4th times 2 to the 5th over b to the 4th. And I could expand it out further if I wanted to, but hopefully you see that this power rule that we're using, it applies to the numerators, meaning all of those 2's being multiplied will become 2 to the 15th in our numerator, but it also applies to the denominators. Whenever I multiply these fractions, I'm multiplying them straight across. b to the 4th times b to the 4th times b to the 4th. Well, that means there's really 12 b's that we're multiplying. In other words, this 5 gets multiplied by 3 to get 15, but this 4 also gets multiplied by 3 to get 12. Okay? In this last example, let's just apply the power rule and not really do any of this expanded notation. Let's jump straight from here to our answer just to practice doing that. So for my numerator, whenever I raise a power to a power, I'm going to multiply. So we've got 6 times 5, which would be 30. That means there's 30 2's being multiplied. That's going to be some huge value. But in our denominator, we have our t, but I'm raising I'm raising a power to a power, and 2 times 5 would give us a 10. And then here there's no exponent on the z, so you always assume there's like a little just 1. I'll kind of highlight it to draw emphasis to it. But then whenever you multiply 1 times 5, you get 5. So that would be the answer to the last one. So we've done 4 examples here of kind of trying to use some of these exponent properties. I've expanded them out all to different points, but really what I want us to know is that shortcut of multiplying the exponents, and that works even when a fraction is raised to a power. Now for these, we're kind of going to be extending and combining a couple ideas. So as always, I just kind of encourage you to try these on your own. Pause the video, give them a shot, and then see if you get what I've got. But I'm going to jump into this first one. On this first one, I'm going to expand or simplify this value on the left first. So that would become 2 to the third, because this is really 2 to the first. And then I have x to the third, same idea. And then y is going to be to the 12th. I'm taking each of these exponents and multiplying them by 3. So that this part that I've boxed in red becomes this. And then we're just multiplying that by x squared y cubed. Now note, this is a little bit different. When I have x to the third times x squared, we're not raising a power to a power. We're just multiplying two values that have exponents. And so what we do here is going to be different than what we did here. Here, if I'm just multiplying these, first off, x to the third times x squared, that means that we have a total of 5x's being multiplied. Here we add exponents. It's called the product rule. Excuse me, yeah, the product rule. And then with our y's, we have 12 being multiplied here. Like if we expanded that out, it'd be 12 y's all being multiplied. And here we have 3 more y's being multiplied. So we really have 15 y's. Once again, add the exponents. And this 2 to the third didn't have anything to simplify with, so I could leave it as 2 to the third, or I could multiply it out and do 2 times 2 times 2, which is 8. And that would be your answer there. And let's do our last one. Our last one right here, I'm going to start by simplifying this value over here on the left. When I raise a power to a power, I multiply exponents. So 4 times 2 is 8. Our q in the denominator is really a q to the first, so 1 times 2 is 2. And then we're going to multiply that times 2p squared over q to the third. And whenever I multiply these, I'm going to go straight across. The 2 here doesn't have really anything to multiply with, so I'm just going to have a 2 in my numerator. And then p to the 8th times p squared, we're going to add those exponents to get p to the 10th. And then q squared times q to the third, we're going to add those exponents and get q to the 5th. So that would be your most simplified version of this last one.